Hello all, recording a lesson here on special right triangles that we discussed today. But in more detail, there are two special right triangles. One of them is called a 30, 60, 90 right triangle. The other one is called a 45, 45, 90 right triangle. Now, in general, we can take the 45, 45, 90 right triangle and write out the legs, which make up the sides that form the right angle, as x and x, because this is an isosceles triangle. And the hypotenuse will then be equal to x radical 2. The 30, 60, 90 right triangle, it's not different, but you do have to be aware of one thing where the 45, 45, 90 right triangle does not have that. And that's because since the legs of the 45, 45, 90 right triangle right there are the same length, that means they're both x and x. But with the 30, 60, 90 right triangle, these legs are not the same length. So it's important to be able to identify the side that's opposite the 30-degree angle. That is your basis of comparison side, right? That is your base, kind of your anchor, right? Because that's just measuring x. Now, if you look over to the hypotenuse of this triangle, 2x is going to be this measure. That's going to be twice the length of this, which I do call a lot as a label. I call it the short side, because since it is across from the smallest angle, that means it is the shortest side of this right triangle. So the short side measures x. That means the hypotenuse measures 2 times x, 2x. And that means opposite the 60-degree angle is going to measure x times radical 3. And then, again, that's off of this length being x. Now, if the 30 and 60 are switched like here on this second 30, 60, 90 right triangle, you're still going to have the same measures of sides, except x is now going to be over on this left side. And I don't really want to say left or bottom or right side, because it's not really going to be based upon that. It's always going to be based on being opposite the 30-degree angle. 2 times x is still the hypotenuse. And since the 60-degree angle is up top, that means opposite that 60-degree angle, down on the bottom, measures this x times radical 3. Now, special right triangles here are going to have a kind of bottom value, which will come into play a lot later on. Well, it will come into play a whole lot in the near future. And that's when x is equal to 1, because what happens is you are allowed to write out your own 30, 60, 90 right triangle and fill in these values here for the sides, right? As long as they are in that scheme where 1 is opposite 30 degrees, 2 is the hypotenuse, radical 3 is opposite 60 degrees. This is going to be correct, and the same is going to hold true for the 45, 45, 90 right triangle, like so. Opposite the 45-degree angles measures 1. Again, both of them. And then opposite the 90-degree angle measures radical 2. And what this is saying is that these are ratios here. This is the ratio of, let's say that this side actually measures 10. Well, that means that the hypotenuse, because this ratio to that ratio is double, this one to this one, the hypotenuse to the short side is double, that means that this hypotenuse gives me twice that also, measuring 10. And then the ratio of the middle to the short side is radical 3, so the middle side is going to equal 10 radical 3. All right, let's take a look at some examples, starting with the 45, 45, 90 right triangle. We know that this measure length here, this leg is equal to 8, and we're going to find the missing lengths A and B. Since this is a 45, 45, 90 right triangle, like so, it told us there, that means that A is equal to 8 because it's the same as this. B is going to be this 8 times radical 2 for a value of 8 radical 2. And that's all there is to it. Now let's look at this, right? The triangle, the right triangle is kind of switched around a little bit, turned a little bit. But again, we're not looking at bottom and left and top. We're looking at opposite certain angles, right? So this 45-degree angle has a measure of 14 units opposite that. That means A on the other side is going to equal 14 as well because it is opposite that 45-degree angle. And opposite the 90-degree angle down on the bottom here is this hypotenuse, right? Again, the hypotenuse can be in different locations if the triangle is drawn differently. But on a 45, 45, 90 right triangle, which is something that you must identify just based on these angles here, the measure of the leg times radical 2 is equal to the hypotenuse. Another 45, 45, 90 right triangle, this one's a little bit trickier because instead of given the value of the legs, we are given the value of the hypotenuse. So if we go back to our general 45, 45, 90 right triangle here, again, this is the location of these x's and x radical 2's is going to change depending on how the triangle is oriented. But the bottom line is that the legs measure x right there, hypotenuse measures x radical 2. So if we were to take this triangle here and write the leg as x and the hypotenuse as x radical 2, this gives us a nice equality on the hypotenuse side. X times radical 2 is equal to 23. And then we can solve for x by dividing radical 2 so that x is equal to 23 over radical 2. Right? And then if you want to be complete about it, if your teacher expects you to rationalize that denominator, then you can certainly do so by multiplying top and bottom by radical 2. And this is the value of x, right? So that means a is equal to 23 radical 2 over 2, and b is equal to 23 radical 2 over 2 as well. Number 4, we're looking at the 30, 60, 90 right triangles now, right? There's 4 and 5, we have 2 of them. We'll start with number 4 first. As far as the 30, 60, 90 right triangles go, you want to be able to identify, the easiest scenario will be to be able to identify what's called the short side. And that is the side opposite the 30-degree angle. So you can take your finger, put it on the 30-degree angle, like you can imagine I'm doing right here, and then draw a line over to the opposite side of this triangle, the other side, and that is going to be the opposite side. So it's equal to 7. And based on this side equaling 7, the hypotenuse is going to equal double that, right? Because remember, our general x values is x, 2x for the hypotenuse, and then x radical 3 for the middle side, right? Short side is x. So that means a is equal to 14. B is equal to 7 times radical 3, because that's what this says over here. We're showing here that x is equal to 7. So b is equal to 7 radical 3, right? We can circle those answers. So this looks like to be the same, right? The difference is, check out where 30 is located on number 4, and check out where 30 is located on number 5, right? We're still given the values of what looks to be the right-hand side of these triangles. But because the 30 and 60-degree angles are swapped, that means that is also going to swap the labels of x and x radical 3. Right, so this is actually just a slightly more difficult problem. Let's give ourselves some space. A slightly more difficult problem because we are not given the value of x explicitly like we were on number 4 up here. Right, so we have a little equation here, x times radical 3 equals 28, very similar to number 3 that we solved. Radical 3 is what we're dividing, so x is equal to 28 divided by radical 3. And once again, if you need to rationalize this denominator, then it's going to be 28 radical 3 divided by 3. So that means b is equal to 28 radical 3 divided by 3. What about a? A is equal to 2x. That's equal to 2 times 28 radical 3 divided by 3, which is going to equal 56 radical 3 divided by 3 after some multiplication. So this is our value of a, 56 radical 3 divided by 3. Number 6, right? Again, I'm trying to throw different orientations of these right triangles at you so that you can get used to, again, I don't want you to get used to trying to identify these sides based on their location, based on left, right, middle, top, bottom. I want you to be able to identify these sides based on where the 30-degree angle is located. Because again, opposite 30 is equal to x, hypotenuse is equal to 2x, and opposite 60 is equal to x radical 3. Now, whatever side you are given, in our case it's this one right here, this is our equation side. This is our side that we can form an equation from. 2x is equal to 19 divided by 2, and that means x is equal to 19 over 2, and that is our value of a. B is going to equal x times radical 3. So that's going to be 19 over 2 times radical 3, which equals 19 radical 3 over 2. So that is our value of b, and thankfully, we do not need to rationalize that. I think one more to do, which will be to solve for this, where, again, opposite 30 degrees is what we want to look for. That's going to be x, hypotenuse, and then middle side. Hypotenuse is 2x, x radical 3 for the middle side, which shows us our basis of comparison. So 10 is equal to x times radical 3. We can divide by radical 3, and x is equal to 10 over radical 3. Let us rationalize that to be 10 radical 3 over 3. And this is our value of a. If we want to find b, that's going to be 2x times x. So that's going to be 2 times 10 radical 3 over 3 for a value of 20 radical 3 over 3. And that is how we solve these special right triangles. Now, if you were asking, why do we need to do this? We know the Pythagorean theorem. If you think about it, we are only being told on this right triangle that this value here, for instance, is 10. right? This one is A, this one is B. So the Pythagorean theorem will say A squared plus 10 squared is equal to B squared. There are two unknowns here, so it is not possible to use the Pythagorean theorem to solve this until we use the property of a special right triangle to get the value of A or the value of B. Then once you do that, you might as well just keep going, and you can skip the Pythagorean theorem altogether for this particular problem. Thank you.